Hi. So for this talk, it's really geared at two different groups of people. For the big bosses here, it's about what we did to overcome various challenges, really, in going to an analytic-driven and machine learning-oriented environment. For the practitioners, I know a lot of you here are, it's something to go tell your big bosses that maybe this is what might be useful. So what it boils down to is that there are two significant points here that were challenges for us and how we overcame them and how this removed a lot of the more traditional obstacles around data-driven analytics and leveraging that for business impact. First, a little bit about what we do. So the Financial Industry Regulatory Authority, FINRA, we protect investors and we regulate securities markets, particularly looking for market manipulation, fraud, these types of activities. We get up to 100 billion events per day coming in, and we integrate this data to create a moment-by-moment graphs of the various orders and trades that are happening in the markets. These are trades that are often algorithmically driven, fueled by machine learning on the other side, and these are feints, probes, fakes, and attempts to move markets is what we're looking for so somebody can profit from them. So there might be an event over here that's correlated to some event over here, and someone over there profits, and it creates an unfair advantage, an unfair playing field, and erodes the trust in the markets. So we store around 30 petabytes. We construct these graphs, and we run the analytics. We get the data from the markets and exchanges, various broker-dealer firms, knit it together, and then out comes results. So this analytic-intensive environment has a number of challenges with it. The first challenge that we overcame in doing this is that of the data. And here, what the challenge was is massive scale, tens of billions, 100 billion events a day coming in. And we keep this for years to run analytics on and look at trends in the markets. And this fragmented and siloed data, which naturally occurs. So in an environment where you assemble data for the purpose of analytic situation A, in service at analytic problem B and C, this creates siloed environments where a lot of the time is spent trying to find the data, figure out where it is, what to do with it, and so forth. The second problem, or challenge around this, is the disjointed development teams that need to work on analytics. So it's the data scientists, the developers that take this and try and turn it into a production system, QC. So there's a software development lifecycle which has traditionally been oriented towards the apps that we're all familiar with, that here is being applied to data science and is not a good fit. That's a problem, because it becomes an impediment to getting things out. And I think a lot of you are facing that challenge. And then the tools. So traditionally, we wrote these analytics in SQL. So you end up with a 100-page SQL statement that somebody's got to debug. And I think it's clear from there the lack of modularity and so on that comes out of that, and reusability. So the way we address the data part of this is one source of the data. We use Herd, which is an open source data management system that we developed, to have one data lake. All our enterprise data, all the big data is in this data lake. There are no pockets of it here, there, or anywhere. And it's all protected with access control and the right security mechanisms. And then the various ingests and outputs all come in and out from this data lake. That solves a wide swath of problems. So there are no ticket-oriented processes to go fetch the data. There are no elves that run around to go find the data that matches with this and that and the other. It's driven by the data scientist. I want this data to the degree that they have access to it, they get it, and they're up and running. This eliminates a large learning curve also. When people come on board to the company, they're productive almost immediately because they don't have to know all the secrets of where the data is and who to go talk to get what. So in our situation, we have various analytic and query tools that run against this based on the needs of the particular applications, from ETL to search and discovery to constrained queries that are generated by user interfaces that go against the data, and the data science applications and the machine learning, which is a large part of what we're focused on, and where we use the Databricks system around that. So once the data's sorted out and it's all there with a catalog and it's accessible, the second topic is the development process that we addressed. Here, we had a series of tools and systems around this that were being used to develop the analytics. And we standardized the big data analytics around the notebook environment with Databricks. And this allows then a different software development lifecycle. So the inherent translations and throwing it over the walls and all those steps in a pipeline that become necessary from disparate development environments evaporate. Before, there was a research group, the data science, do a prototype, the white paper, here's what we want, here's the data, it's got to go to production, it goes to another group to figure out how to code this so that it can go into a scalable production environment, the QC, and so forth. You can see how that works. The after of it is we have one combined team with various roles on the team, and there is one unit of work that's being worked on, which is the notebook. So the test cases are in the notebook, the code is all in the notebook, the documentation is in the notebook, and the notebook is the unit which makes its way and is finally deployed into production. So this changes the dynamics, the sociological aspects of various teams and who handed off to who, and where was the problem, and the high cost of iteration. And it creates a situation where the people that are less familiar with the subject matter and the domain are working hand in hand with those who are domain experts and the data scientists. It changes the dynamics dramatically. So this is a game changer for us, combined with the other situation. So what happens out of this then is our AI analytics traditionally were SQL, we call them patterns, developed in SQL and running on a framework against the data appliances, proprietary data appliances that we bought. We had moved to Hive, again with SQL. And now we're in a situation where we have a unified data analytics platform underneath for the development process, going against the one data repository, so you can pull everything as I was explaining earlier. And then from this, we've got people developing in Scala. So we have modular software being written, reusable feature framework, going into a machine learning framework, and then the development on that. So what this has done for us is, it's fairly clear, it's removed a lot of the obstacles that are inherent, that seem inherent in doing data science and machine learning for business purposes, where it's a production environment and you have to have real business impact on what you do. It's focused the data scientists that we have on the data science, not the scavenger hunts that are inherent in finding the right data, figuring out where it is, wrangling it, and so on. The third is an important aspect, is it's lowered the cost of curiosity. So because the overheads are not there and the friction costs evaporate, curiosity in exploring the data to be able to look for hunches and look for new relationships, subject to security and permissions for the data scientists, that cost is lowered. And then the step from there to take it into production is minimized. Because it's one thing to take a small collection of data, it's another thing to take it to production. And finally, the delivery velocities, which are critical in our business, have been altered. So that's the, so I think with these two premises in mind, I mean, that's what I would boil down to the wisdom of what we've done. And I hope it's useful.